Okay, today I'm going to show you how to balance chemical equations. And this is going to seem super difficult at first, but it's not. It's basically just a numbers game. So with any chemical equation, what you're going to have are the reactants. That's going to be everything on the left-hand side of the arrow. And then those are going to form the products. Products are everything on the right-hand side of the arrow. It does not matter if there are 15 things over there, or if there's one thing, it's still a product or products. It doesn't matter if there's one thing over here or three, it's still the reactant. It's a reactant. So we got reactants forming products. Okay. In other words, you can hear this sometimes referred to as yields or makes, but this is just what it's making, so what it's forming. All right, so let's look at this worksheet. Okay, so over here on number 1, we have hydrogen and oxygen forming water. Okay, so what we're doing is we're looking at the subscripts and seeing how many we have on each side. So if you need to keep a tally, you can do that, or just keep up with it in your head. Over here, we have hydrogen, and we have a subscript of 2. Let me see if I can get a little bit closer to that. Maybe. There we go. Okay, so we have 2 hydrogen here, and we have 2 hydrogen on this side. So the hydrogens are balanced. Over here we have 2 oxygens, and if there's nothing after it, it's like there's a 1 there. If you need to put that 1 in there, that is perfectly fine. It just won't be written like that in a real chemical equation. But if you need it there for visual, I guess, support, then you can do that. All right, so we have 2 hydrogen and 2 hydrogen. So the hydrogens are balanced. Then we have 2 oxygen and 1 oxygen. So what we're going to do to balance the formulas, you're going to add a coefficient, which is a big number on the outside of the chemical formula. We're going to put a 2 there. That 2, therefore, multiplies through to everything in that chemical formula. You can't split the chemical formula up. So now we have 2 times 2, which is 4 hydrogen, 2 times 1, which is 2 oxygen. Okay? Alright, so now our oxygens are balanced because we have 2 times 1, which is 2, and we already have 2 over here. But we changed the number of hydrogen to 2 times 2, which is 4, and over here we just had 2. So to get 2 to 4, the number that has to be multiplied by is 2. So now we have 2 times 2, which is 4. We have 2 times 2, which is 4. We have 2 oxygen and 2 times 1, which is 2 oxygen. So the equation is balanced. This did not need anything. You can put a 1 in there if you need to. So if we were to write the coefficients for this equation out, where you would see this is like on an end of course test. It would say, what are the coefficients for a correctly balanced equation? It's just going to show you the coefficients for the blanks. So the coefficients for these would be 2, 1, 2. Okay. All right, let's look at the next one. We have 2 nitrogen. We have 1 nitrogen. We have 2 hydrogen. And then we have 3 hydrogen. Okay. So I would probably start with the hydrogen first and get them balanced up. Okay. Smallest number both of these go into is 6. To get 2 to 6, you're going to multiply this by 3. To get 3 to 6, you're going to multiply this by 2. Okay, so now we have 3 times 2, which is 6 hydrogen, 2 times 3, which is 6 hydrogen. Remember, there's nothing after this, so it's like there's a 1 there for nitrogen. So now we have 2 times 1 for nitrogen, which is 2, and we have 2 right there. So the coefficients for that equation would be 1, 3, 2. So 1 in this blank, a 3 in this blank, and a 2 in this blank. So all you're doing is you're going back and forth. The arrow is what's dividing the sides. So you have to have the same number of atoms on the left-hand side as the right-hand side. This is because of the law of conservation of mass. And the law of conservation of mass just says matter cannot be created or destroyed. So if you have 4 hydrogens here, you had to end up with 4 hydrogens over here. You can't change the number of atoms that you have because that wouldn't support the law of conservation of mass, which is just matter cannot be created or destroyed. It has to be moved around or rearranged or bonded with something else. Okay, let's look at number 3. We have S8O2, and then we have SO3. Okay, so let's look at the oxygens first. 2 and 3. The smallest number that both of those go into is 6. So I can already tell that that's not going to be right because this would be 6 sulfurs and we have 8 over here. Well, let's try to balance the sulfurs. 8 and 1. So if we put an 8 in front of this to balance up those sulfurs. Now, how many oxygens does that leave us with on the right-hand side? So we put that 8 there, and there was already a subscript of 3. So 8 times 3 is 24. We have 24 oxygens on this side. Okay? Over here, we have 2. What times 2 equals 24? So that's going to be 12. Okay, because 12 times 2 is 24. So that's balanced up our oxygen. So we have 12 times 2, which is 24. Okay, and then that's 8 times 3, which is 24. And remember, it's like there's a 1 here for sulfur. 8 times 1 is 8. And then we already had an 8 subscript there. So the coefficients are 1, 12, 8. If you ever look at your coefficients and they can be reduced down, then you need to reduce them down. So if you've worked this out and it was 4, 2, 4, and 2 could go into all of that, reduce it down to 2, 1, 2. Okay, they always need to be reduced down because it still will work out balanced. If you had a 4, 2, 4 here, it's just 2 could go into all those. So you need to balance them out or reduce them down. All right, let's look at the next one. N2, N2. So we have 2 on each side. Oxygen, we have 2. Oxygen, we have 1. So we're going to balance out that oxygen. We're going to put a 2 in front of it. So now we have 2 times 1, which is 2. And we have 2 oxygens right there. But we changed the number of nitrogen. Remember, this multiplies through to everything in that chemical formula. So now we have 2 times 4 nitrogen, which is 4. And we only have 2 over here. So we're going to add a 2 subscript to that. So now we have 2 times 2, which is 4, 2 times 2, which is 4, 2 times 1, which is 2, and 2. So the coefficients for that equation are 2, 1, 2. Let's look at the next one. All right, we have mercury and oxygen. We have 1 of each one of those. We have mercury here, and oxygen has 2. Okay, so the oxygens are not balanced. So we have 2 here and we have 1 here. So we're going to put a 2 subscript or 2 coefficient in front of that, not subscript. So now that balances out our oxygen, but it'll also change the mercury to 2 because it's like there's a 1 here. Okay. So 2 times 1 is 2, and we only have 1 here, so we're going to put a 2 in front of that. So now we have 2 mercury, 2 oxygen, and 2 oxygen. Coefficients for a correctly balanced equation in this is 2, 2, 1. Okay, number 6 looks really difficult, but it's not really. This is actually the equation for photosynthesis. So you take carbon dioxide and water, and it makes sugar and oxygen. Remember, carbon dioxide is what the trees take in. That's what we breathe out. It needs water. It makes sugar. That's what the trees use for energy. And then the oxygen is a byproduct. It kind of breathes it out, and then we breathe it in. Okay. So this goes along with the carbon cycle. It actually shows you how the carbon is cycled through nature. All right. I would probably start with the carbon or hydrogen. All right. You have 6 carbon here. You have 1 here. So we're going to put a 6 in front of this. Okay. You have 12 hydrogen here, and we have 2 here. So if we put a 6 in front of that, that's going to balance out the hydrogen. So now we have 6 times 2, which is 12, and we have 12. We have 6 carbon. So over here we have 6 times 1. Now we need to look at the oxygen. Okay. Over here, we'll see how many we have over here right now. 6 times 2 is 12. Okay, so we have 12 oxygen right there, but we also have some oxygen in this compound. So it's 6 times 1, which is 6. So altogether we have 18 oxygen on this side. And this is a really difficult one. Don't get overwhelmed by this one. I'm just showing it to you because it's one that you'll see in biology and everything else. All right, so we have 18 oxygen on this side. Over here we have 6 and we have 2. All right, so we've already used up 6 right here. We are not going to change anything with this because we use that 6 and that H in the carbon and that 6 and that 12 for carbon and hydrogen to balance up this other stuff. So we're going to try to stay away from messing with this. We're going to use this oxygen over here by itself. So we have 6 here. 6 plus what is 18? So 6 plus 12 is 18. So we need this number to add up to 12. 2 times what is 12? So 2 times 6 is 12. So we have 6 times 2, which is 12. And then we have 6 over here, which is 18. So we have 18 oxygen on this side, and we said we had 18 on that side. So the coefficients for that equation are 6, 6, 1, 6. And that is your equation for photosynthesis. All right, let's look at number 7. We have 1 zinc, 1 chlorine, 2 chlorines, 1 hydrogen, 2 hydrogen. So our chlorines and hydrogens are not balanced. You have 2 of each on this side, 1 of each on this side. So we're going to add a 2 right there. So now we have 1 zinc, 2 hydrogens, 2 hydrogens, 2 chlorines, and 2 chlorines. So it's balanced. So the coefficients for that equation are 1, 2, 1, 1. Okay. Let's look at silicon and chlorine. Okay. So we have 4 chlorine here, and we have 1 chlorine here. So I'm going to go ahead and add a 4 to this one. That gives us 4 chlorines. Now that gives us 4 and 4, which is 8 hydrogen for this side, because we have 4 here, and we have 4 times 1, which is 4 here. But remember, it's divided by the arrow. So I have 8 hydrogen on this side, We have 2 on this side. So if we put a 4 there, that's now going to